The year is 2154. Our planet has been ruined by environmental catastrophe. In the movie Avatar, greedy prospectors from Earth descend on the world of an ancient hunter-gatherer people named the Na'vi. Their home is a lush moon far beyond our solar system named Pandora. Could such a place exist? And could our technology and our appetite for exploration one day send us hurtling out to reach it? In fact, the supposed site of this fictional solar system is one of our most likely real interstellar targets, until a better destination turns up. Pandora orbits a fictional gas planet called Polyphemus. Its home is a real place, Alpha Centauri, the brightest star in the southern constellation of Centaurus. At 4.37 light-years away, it's part of the closest star system to our Sun. Alpha Centauri is actually two stars, A and B, one slightly larger and more luminous than our own Sun, the other slightly smaller. The two stars orbit one another, swinging in as close as Saturn is to our Sun, then back out to the distance of Pluto. This means that any outer planets in this system, anything beyond, say, the orbit of Mars, would likely have been pulled away by the companion and flung out into space. For this reason, Alpha Centauri was not high on planet hunters' lists, until they began studying a star 45 light-years away, called Gamma Cephei. It has a small companion star that goes around it every 76 years. Now it seems it also has at least one planet. That world is about the size of Jupiter, and it has planet hunters excited. Perhaps 2/3 of all the stars in our galaxy are in so-called binary relationships. That means there could be many more planets in our galaxy than astronomers once assumed. At least 3 teams are now conducting long-term studies of Alpha Centauri, searching for slight wobbles in the light of each companion star that could indicate the presence of planets. If they find a planet that passes in front of one of the stars, astronomers will begin intensive studies to find out what it's like. One of their most promising tools will be the James Webb Space Telescope, scheduled for launch in 2014 or 2015. From a position 1 million miles away from Earth, it will deploy a sun shield the size of a tennis court and a mirror over 21 feet wide. The largest space telescope ever built, it will offer an extraordinary new window into potential solar systems like Alpha Centauri. With its infrared light detectors, this telescope will be able to discern the chemical composition of a planet's atmosphere. And perhaps whether it harbors a moon like Pandora. One prominent planet hunter predicted that if a habitable world is found at Alpha Centauri, the planning for a space mission would begin immediately. Here's that star duo seen by the Cassini spacecraft, just above the rings of Saturn. To actually get to this pair of stars, you'd have to travel as far as the orbit of Saturn, then go another 30,000 times further. Or put another way, if the distance to Alpha Centauri is the equivalent of New York to Chicago, then Saturn would be just 1 meter away. So far, the immense distances have not stopped us from launching missions into deep space. In 1977, the twin Voyager spacecraft were each sent on their way aboard Titan III Centaur rockets. After a series of gravitational assists from the giant outer planets, the spacecraft are now flying out of the solar system at about 40,000 miles per hour. They're moving so quickly that they could each whip around Earth in just 45 minutes. twice as fast as the International Space Station. Voyager 1 has now traveled over 110 astronomical units. That's 110 times the average distance between Earth and Sun, or about 10 billion miles. But don't hold your breath. If it was headed in the right direction, it would need another 73,000 years to travel the 273,000 astronomical units to Alpha Centauri. When it comes to space travel, we've yet to realize the dream forged by rocketeers a century ago. A Russian schoolteacher, Konstantin Tsiolkovsky, inspired generations of space visionaries with sophisticated ideas about multi-stage launch vehicles. He imagined the construction of space stations in Earth orbit, and eventually vast permanent space colonies. In time, he predicted, we'd evolve into a whole new species, Homo cosmicus. Since then, rocketry's greatest advances have centered on ways of containing explosive propellants and methods of maintaining stable flight at high speeds. The problem is that chemical rockets are just not efficient for long-distance space travel. To reach the speed needed to enter orbit around Earth, 17,500 miles per hour, the space shuttle must carry 15 times its weight in fuel. And that's efficient compared to some other rocket systems. And you'd need to be traveling more than 25,000 miles per hour to break free of Earth's orbit and go anywhere else. A NASA study showed that to send a space shuttle-sized craft to Alpha Centauri in 900 years would take an unbelievable amount of fuel, 10 to the 137th kilograms of rocket propellant. Suffice to say, it's more mass than is in the entire visible universe. While only a very tiny percentage of NASA's budget goes to advanced propulsion, there are some promising ideas on the drawing board. Rockets powered by nuclear fuel, or plasma, a supervolatile gas. Huge sails pushed along by the pressure of photons from the sun. Ion drives. But to reach Alpha Centauri within a human timescale, we'll have to go with the most potent fuel in nature that we currently know. It's the science fiction fuel of choice, antimatter. In James Cameron's Avatar, hybrid nuclear fusion and antimatter engines power a mile-long interstellar spaceship. At a speed of 670 million miles per hour, this vehicle makes the journey to Alpha Centauri in just 6 years. Antimatter really does exist, as the mirror image of the universe we know. It consists of electrons and protons, but with their electrical charges reversed. Whenever it comes into contact with normal matter, the two annihilate each other in a ferocious blast of energy. Large amounts of antimatter were created and destroyed in the fiery dawn of our universe, the Big Bang. But somehow, in one of the great mysteries in science, we were left with a universe whose visible substance is almost all normal matter. The universe still produces antimatter through powerful collisions, such as a jet from a black hole slamming into a cloud of gas. When matter and antimatter obliterate one another, they emit gamma radiation that we can then detect with instruments such as the Fermi Gamma Ray Space Telescope. Fortunately, black holes aren't the only way to generate antimatter. In giant labs, like the Large Hadron Collider, scientists accelerate atoms to nearly the speed of light and blast them together to expose their fundamental constituents. Small amounts of antimatter can be made this way, but it's incredibly expensive. With a dedicated facility, the cost of producing it might come down far enough to produce usable amounts. And that's the hope of one researcher. Dr. Gerald Smith has been working for over a decade to find a way to trap this volatile substance and store it in isolation from the rest of the universe. Smith and his colleagues have designed a trap the size of a cigar case. It sits within a tank filled with liquid nitrogen and liquid helium, designed to cool it down to 270 degrees below zero. Once injected into this trap, antimatter particles are suspended by magnetic fields within a vacuum as empty as deepest space. But the problem is that anti-electrons, called positrons, tend to repel each other explosively. That makes it tough to store more than a few at a time. This team now believes it may have discovered a pathway to storing large amounts over longer periods of time. Their solution lies in combining positrons with electrons, forming an element called positronium. In theory, with the right magnetic fields, these electrically neutral atoms might be held indefinitely. When released under controlled conditions, ultra-high energy antimatter beams could turn out to be ideal cancer killers, or lead to revolutionary industrial applications. Or perhaps, one day, they could power long-distance spaceflight. It wouldn't take much. Antimatter is so potent that it defies common sense. A chunk the size of a small coin could propel the space shuttle into orbit. Smith estimates that once in low Earth orbit, a human mission to Mars would take as little as 10 milligrams worth. The basic idea of an antimatter rocket is simple. A beam of positrons is released into the engine core, where it annihilates the surface of a metal plate. That creates an explosion that propels the craft forward. Another design uses a sail. A cloud of antimatter particles reacts explosively to its surface, propelling it forward. Short of traveling to another solar system, there may be good reasons to contemplate developing antimatter propulsion. A preliminary mission would speed beyond the orbit of Pluto, sending back close-up images of dark planet-like objects that ring the solar system out in the Kuiper Belt. A longer-distance probe could reveal new details about the Oort cloud, a vast realm of comets that envelops the solar system. Once out there, it could sample particles that make up the interstellar medium, or send back unique data sets on dark matter, the invisible stuff that makes up the overwhelming portion of our universe. To make it all the way to Alpha Centauri within 50 years, an antimatter probe would have to gradually accelerate to around 10% the speed of light. That's 67 million miles per hour. It would then gradually decelerate as it approached its destination. At those speeds, hitting even a grain of dust could destroy the spacecraft, so it might be best to slow the journey down to a century or more. It's safe to assume for now that we would only send a probe to Alpha Centauri if we discovered a habitable world. There may be other choices in our solar neighborhood. They include Proxima Centauri, a red dwarf star 4.2 light-years away that may be gravitationally bound to Alpha Centauri. Beyond that, not quite 6 light-years away, is Barnard's star. Or there's Lalande 21185, a red dwarf 8.3 light-years away. we already know it has 2 Jupiter-sized planets. There are at least 22 stars within 12 light-years of Earth. And any way you look at it, the first interstellar voyage will be a quantum leap for humanity. The urge to reach out to distant horizons, to climb the highest peaks, to push ourselves past our perceived limits, seems to be a vital part of what makes us human. Yet, explorers of old set off not just because it was there. At times it was greed, hunger, fear, or despair that propelled them outward from their homelands and allowed them to endure their long journeys. Whether we attempt to make this leap to the stars may come to depend on how we regard this planet. To the physicist Stephen Hawking, the journey is imperative. "I don't think the human race," he said, "will survive the next 1,000 years unless we spread into space. There are too many accidents that can befall life on a single planet." Indeed, we can't foresee the impact of wars, social upheaval, or the course of human civilization in coming centuries. But today, we can see the often conflicting trends that could one day propel us out into the interstellar void. On one hand, the technological advances that might make such a mission possible could revolutionize many other aspects of life on this planet. The ever-increasing rate at which numbers of transistors can be placed inexpensively on computer microchips has become a metaphor for the advance of all technologies in this century. From a few thousand transistors on the first printed circuits of the 1970s, computer chips now have billions etched onto their surfaces. Even that number could seem amazingly small in another few decades. Many observers forecast a steep rise, even an acceleration, in the pace of invention and basic research, and for whole new solutions to the problems of energy, food production, health, and more. On the other hand, major periods of scarcity may loom. In the 20th century, the world saw the largest increase in its human population, from less than 2 billion up to 6 billion. The world's population is now around 6.8 billion. It's expected to reach 9 to 10 billion by the year 2040, with the biggest gains in Asia and Africa. According to a recent UN report, the world will have to produce 70% more food by the year 2050, and at least that much more energy to sustain its population. The scarcity of just simple clean water in some regions is already frightening. Now throw in environmental impacts, like rising sea levels, or the spread of deserts linked to a gradually warming climate. The culprit, to most scientists, is rising emission of greenhouse gases like carbon dioxide since the start of the Industrial Revolution. This map charts rising temperature readings from the year 1885 through to the present. In some places they've gone up by as much as 2.5 degrees Fahrenheit. Computer models project the trend out to the end of this century. Depending upon population growth, energy use, and conservation, temperatures could rise anywhere from 2 to 11 degrees more. Will technological advancements allow us to halt the degradation of our natural environments and increase the carrying capacity of our planet? Will we find ways to mitigate the impacts of war, natural catastrophes, or political upheavals? No doubt, if or when we launch our first mission beyond this solar system, the occasion will spur reflection on who and what we have become as a people, as a planet, just as the first missions to the moon and our neighboring planets once did. At first, we'll send a probe designed to relay basic information on what's there. on a world whose light we have only studied from afar. As this cosmic emissary makes its way across the void, we on Earth will continue to struggle in our pursuits of happiness and prosperity, or of mere survival. When it arrives, we'll scan the data for evidence of a world like our own, one that may harbor life. How will our perspectives on that world, and upon our own, have changed? The year is 2154. Our planet has been ruined by environmental catastrophe. In the movie Avatar, greedy prospectors from Earth descend on the world of an ancient hunter-gatherer people named the Na'vi. Their home is a lush moon far beyond our solar system. Its home is a real place, Alpha Centauri, the brightest star in the southern constellation of Centaurus. At 4.37 light-years away, it's part of the closest star system to our Sun. Alpha Centauri is actually two stars, A and B, one slightly larger and more luminous than our own Sun, the other slightly smaller. The two stars orbit one another, swinging in as close as Saturn is to our Sun, then back out to the distance of Pluto and Planet. That world is about the size of Jupiter, and it has planet hunters excited. Perhaps 2/3 of all the stars in our galaxy are in so-called binary relationships. That means there could be many more planets in our galaxy than astronomers once assumed. At least 3 teams are now conducting long-term studies of Alpha Centauri, searching for slight wobbles in the light of each companion star that could indicate the presence of planets, named Pandora. Could such a place exist? And could our technology and our appetite for exploration one day send us hurtling out to reach it? In fact, the supposed site of this fictional solar system is one of our most likely real interstellar targets, until a better destination turns up. Pandora orbits a fictional gas planet called Polyphemus. This means that any outer planets in this system, anything beyond, say, the orbit of Mars, would likely have been pulled away by the companion and flung out into space. For this reason, Alpha Centauri was not high on planet hunters' lists, until they began studying a star 45 light-years away, called Gamma Cephei. It has a small companion star that goes around it every 76 years. Now it seems it also has at least one